Hey folks, Segasonicfan here, and I'm just showing off a silly fun project. Nothing too earth-shattering or mind-blowing here, but it was something for fun that I really wanted to do. And that is sort of upgrade and make a dimmable LED light out of this really nice, I think it's got an iron base. It's really quite heavy, and it's got this great gooseneck cord. This is an old IKEA lamp that I got for $1 at a garage sale from a very nice neighbor, and it just had one brightness setting. It's really quite simple. It's got a 3.7 volt power supply, so it doesn't even convert anything. Although the power supply is cool. It's kind of transparent case. It's got a transparent case, and obviously does the AC to DC. But previously this had the on and off switch was one of those like old style ones that was on the cord itself that you clicked, on the power cord. And it didn't even have this plug. I added that plug. So it had just a cord coming out and then just a rocker switch. Not a rocker switch, I forget what those are called though, but the knob style. And so, very, very limited functionality. But it's such a good quality build and such a nice lamp. I was using it so much, but I was like, oh, I'd like it if it dimmed and was, something I could unplug and move around. So lo and behold, I did that. Now I could have done this all with a microcontroller. I might actually do that in the future and do some upgrades and changes to it, especially because I'd like to have it be remote controlled. And if I'm going to do that, I really need a microcontroller. But just getting rid of some old hot glue. But what's cool about this is there's no microcontroller at all. In fact, there isn't even a 555 timer. And so now it's got an on and off button, which it didn't have before. And it's got this really nice linear fader dimmer switch, or dimmer knob potentiometer. This is a nice rubberized thing as well. And if I turn off these other lights, you'll be able to see that it works quite well. And then when you shut it off, you have that little red light just letting you know where it's located. So yeah, it latches nicely. It's got a nice PWM dimmer, and it's doing an on and off switch. It's doing all of this with no microcontroller. So how is that working? Well, there is a 74HC14 Schmidt trigger. There's a 7474 flip-flop. And this is a 74HC4053 MUX multiplexer. And so how it's achieving this is a board, by the way, I used to sell a long time ago before it became clear that no one knows how to use it, including myself. After enough time has passed, I had to look up my old notes. But how this works is the 7474 latch and the 74HC14 Schmidt trigger work in conjunction to create a debounced latched button, which is what this is. And that works quite well. And there's just an LED, toggling the state, the output, the Q output of the 7474. And but the interesting part is actually the Schmidt trigger. One of the input outputs is used in a feedback loop to create an RC oscillator. And then to make it a PWM oscillator, pulse width modulation, there's two diodes and a potentiometer. And so it feeds back to itself through two different diodes in opposite, one's forward biased, one's reverse biased. And then the potentiometer and a capacitor makes an RC circuit to oscillate. And so depending on the state of the potentiometer, it will correspond to the rise and fall time of the RC circuit, the capacitor and the resistor that's being formed at the potentiometer. Anyway, I'll try to post a link below the circuit. It's pretty ingenious, pretty cool. And the only big problem I had with this was I was getting an annoying like humming sound at different brightness levels. And so I re-looked at that circuit and did some calculations with RC frequency, because I sort of intuited that would have to do with a oscillating frequency within the audible range of the human ear. And indeed it was. So by changing that RC capacitor for the Schmidt to a 1 microfarad instead of a 0.1, it's now not at all audible to me. Lastly, the multiplexer is used to switch on the backside of this. There's actually, I forgot to mention on the backside of this, there's also a MOSFET. There is a P channel, I believe it's a P channel FET. And so the multiplexer is being used to trigger that P channel FET. Now, I guess I probably could have just used probably could have just driven the gate of the FET with the 7474, but the multiplexer is already there. Does a fine job of switching that gate on and off. Actually, no, it can't. It's not just on and off because it has to switch it between the PWM. So yeah, that's where the multiplexer comes in. So the multiplexer switches it from an off state to the PWM output and does a fine job of it, as you can see. And so after that, I just added a flex cable. This is a 1 millimeter pitch because those are easier to solder than the more common 0.5 millimeter pitch. And this is a 6-pin connector. The reason why it's 6-pin instead of 4, because you might think, well, you can get away with 4. It's because none of the 3 potentiometer inputs are actually ground. The wiper goes to the RC network, and then the 2 other pins go to the diode, 2 different diodes that are feeding back. Very unusual configuration, but since there's not a shared ground between the button and the potentiometer, it does actually require 5 pins. 5-pin connectors are not very common, so I used a 6-pin. What's also really cool about this is it's magnetic. So I just glued some coin magnets on the back, and you can move this around if you want to. But this was I used to originally have this glued with some foam. I had some foam tape and some other stuff on here, and this configuration is much nicer because it preserves the base. Now, if I want to, I might actually, more likely, we'll probably do this later. Use my vinyl cutter to make some smooth circular discs that I will, with sticker paper, that I'll put on the back of these magnets, so that way it can slide without possibly scratching the surface of this base. Yes, I'm overthinking this. This is a cheap lamp, but I really like it. If I didn't like it so much, I wouldn't have gone all this work. It's a really fun project. And then, of course, eventually, 3D printing or doing some kind of case construction to protect everything would be a good idea. But right now, it sure looks cool, and it's such a simple circuit that even if I were to spill on this and break this somehow, I mean, I'm really unlikely I'd break the LED, and I would just replace one of the chips. It's not a big deal. I also added, like I said, I also added this barrel jack connector, which was hard to do because this is all iron core under here. And then I added some JST connectors for pluggable connectors over here, so I can service, upgrade and change things if I want to. What I think I'm going to do, what I'm planning to do as a future idea for this, just to go even more bonkers, is I actually want to route a really nice thick piece of wood to put on the bottom of this, and then I will seat this in the middle, because I'm going to route it with an open cavity, and then maybe another piece of wood under that. And it would give this really nice wood accent to it. Is already a very beautiful lamp. Also worth noting, at Thingiverse, they have someone designed a cone cover for this, 3D printed cone cover thing, which makes it a little softer, a little bit less direct of a light source. So yeah, that's it for these crazy hacks. If you're interested in the stuff that I'm using here, let me know, and I can still sell these if people want. They're pretty cheap and pretty cool little DIY circuits. As far as the potentiometer, this thing you'll have to source yourself, because I don't know how easy these are to find. I imagine you can get them around, but this was salvaged, and these buttons are very common. You can get these buttons. Anyway, all these parts are pretty sourceable, but I somehow doubt there's going to be that much interest in developing a bill of materials for all this. But anyway, fun little project. Cute little light dimmer. I use this every day, all the time. It's my favorite light. So that's why I went to all this effort. This is Segasonicfan saying, have fun making analog hacky circuits. Signing out.